So we know for a relation we need two sets, A and B. So if B happens to be A, then we say that R is a relation defined only on A because both the sets are same. We have a nice pictorial representation for a relation defined on a single set. That means a relation wherein the first and the second set are same. And that pictorial representation is called directed graph. It is very easy to draw and it is drawn in the following way. Suppose I have a relation R from the set 1, 2, 3, 4 to 1, 2, 3, 4 like this. Then to draw the directed graph, we have to draw 4 points. We will label each point as the members of the set A, which is 1, 2, 3, 4. Okay. Now in my relation, I can observe that 1 is related to 2. So I will draw a ray starting from 1 and going towards 2 with a direction. Okay. Also I can observe that 2 is related to 3. So there will be a ray from 2 to 3. Also 1 is related to 4. So I'll draw a ray from 1 to 4. Also 4 is related back to 1. So I'll draw another ray which is going from 4 to 1. Also I can observe that 3 is related to itself. So in this case I'll draw a loop starting from 3 and ending at 3. So this graph is called directed graph corresponding to the relation. This helps us to visualize the nature of the relation. It will be useful for the further topics. Look at this following relation S. Now you can try to draw the directed graph for the same S. If you need solution, please drop a message in the comment section. Now we will discuss different types of relations. The very first is reflexive relation. The formal definition goes like this. Let R be a relation defined on A. That means R is a subset of A cross A. Then this R is said to be reflexive if X is related to X for all X in your set A. That means all the elements should be related to itself under this relation R. Then we will declare that R is reflexive. For example, the first relation R, which is defined on the set 1, 2, 3, is it reflexive? No, because here 3 is not related to itself. 1 is related to itself. 2 is related to itself. There are other members, there are other relations. But 3 is not related to itself. For reflexivity, all the members of A should be related to itself. But here 3 is not related to itself. So the first relation is not reflexive. Second relation S, which is defined on the set A, B, C, D to itself. Is it reflexive? Yes, it is reflexive because A is related to itself, B is related to itself, C is related to itself, and D is related to itself. Yes. We can conclude about reflexivity by looking at the matrix of a relation as well. So for the first relation, we can observe that the matrix of that relation, which is MR, is like this. Now in this matrix, if all the diagonal entries are 1, then we declare that the relation is reflexive. If any one member of the diagonal is 0, then we declare that the relation is not reflexive. Now look at the third example and check whether it is reflexive or not. You can post your answer in comment section. We can also check whether the relation is reflexive by looking at the directed graph. So for the first example, the directed graph looks like this. If there is a loop at each and every point, then the relation is reflexive. But here I can see that there is one point which does not contain loop. Okay, so that relation won't be reflexive. But for the second example, the directed graph looks like this, wherein all the points contains loops. That means all the elements are related to itself. Hence, the second example is reflexive. We will discuss more example in the next video.